Welcome to solverfy.
So now we'll work on problem 84 from chapter 17. In this problem, we're told that rainwater is acidic because carbon dioxide dissolves in the water, creating carbonic acid, H2CO3. If the rainwater is too acidic, it will react with limestone and seashells, which are principally made of calcium carbonate. Calculate the concentration of carbonic acid, bicarbonate ion, and carbonate ion that are in a raindrop that has a pH of 5.60. Assume that the sum of all three species in the raindrop is 1.0 times 10 to the minus fifth power. So first, we can write our two equilibrium that will describe the equilibrium between these three species. So first, we have carbonic acid in equilibrium with HCO3 minus and H3O plus. And then the HCO3 minus will be in equilibrium with the carbonate, CO3 2 minus and H3O plus. And our Ka1 is equal to 4.3 times 10 to the minus 7. And Ka2 is equal to 5.6 times 10 to the minus 11. So now we need to write down a couple things to remember. The total concentration is equal to H2CO3 plus HCO3 minus plus CO3 2 minus. And we're told that's equal to 1.0 times 10 to the negative fifth molar. And we can also calculate the the concentration of H3O, or hydrogen ions, because the pH is 5.60. So we take the inverse log of negative 5.60, and we get a value for the H3O plus concentration of 2.51 times 10 to the minus 6 molar. So now let's write down the equations for K1. And so we know that this equation is products over reactants. So we have HCO3 minus times the concentration of hydronium, which we just calculated to be 2.51 times 10 to the minus 6. And this is divided by H2CO3 concentration. And all of this is equal to 4.3 times 10 to the minus 7. So we can solve for this ratio of HCO3 to H2CO3. And it is 0.71, 171. We can do the same thing for Ka2. It's concentration of products over reactants, so CO3 2 minus concentration of hydronium, which we know to be 2.51 times 10 to the minus 6, divided by concentration of HCO3 minus, and we can show that this is equal to 5.6 times 10 to the minus 11, and we can again get this ratio. CO3 2 minus over HCO3 is equal to 2.23 times 10 to the minus 5. So now we can open up a new sheet and solve for these concentration values. So both of these ratios here, we can plug in So we can solve for the concentration of bicarbonate, HCO3-. So we're told that the total concentration for both of them, for all three of them, is 1.0 times 10 to the minus fifth. So this is equal to carbonic acid concentration. But if we solve this expression for H2CO3, what we get is HCO3- divided by 0.71 is equal to H2CO3. So we substitute that in here. We have HCO3 from the initial expression, and then we need to substitute for the carbonic acid. So we solve this question here for the carbonate ion, and we get HCO3 times 2.23 times 10 to the minus 5. So we can solve this equation by adding up the HCO3 values and then dividing what we obtain by 1.0 times 10 to the minus fifth, and we get a value of 1.46 times 10 to the minus 6. So this is our first value here that we're asked to find. The concentration of H2CO3 we can find by plugging this value into this expression, and we get 1.46 times 10 to the minus 6 divided by 0.171, and that'll be equal to 8.54 times 10 to the minus 6. Then finally, the carbonate concentration, CO3 2-, we calculate by plugging in this value here, and we get 1.46 times 10 to the minus 6 times 2.23 times 10 to the negative 5 is equal to 3.26 times 10 to the negative 11 molar. So these three values are the values that we are asked to calculate.